For this example, we're going to evaluate this integral. We got the integral of 1 over the square root of 4 minus 9x squared. Now your problem may have different numbers here. So since we've got a minus, we're subtracting an x squared in here, I'm going to use trig substitution, and for my substitution I want to have x equal to sine theta, but I need to multiply by something out front here so that when I substitute in and I multiply here, I want to get a 4 so that I can pull the 4 out of this square root. So to do that, I'm going to divide by the square root of 9, so divide by 3, and then multiply by the square root of 4, which is 2. So my substitution, I'm going to have x equals 2/3 sine theta. Then taking the derivative, dx will be 2/3 cosine theta d theta. And so we can substitute back in at the end. I want to solve for theta, and that will be inverse sine of 3/2 x. And that's just multiplying by the reciprocal over here, so I have 3/2 x, and then taking the inverse sine. So now I want to make this substitution in my integral. So I have 1 over, I'm going to have the square root of 4 minus 9 times 2/3 sine theta squared, and now I need to substitute in for my dx, and that's going to be 2/3 cosine theta d theta. So let's do a little bit of simplification. I'm just going to pull the cosine up on top here, so I have 2/3 cosine theta on top, and then I'm going to simplify my square root here, so I've got 4 minus, and we chose this fraction so that when we square it and multiply by 9, I'm going to get 4 and a sine squared theta d theta. We're taking the integral still. So now I'm just going to pull a couple of constants out front. So first I'll pull out this 2/3 here, and then I've got a 4 in my square root on the bottom, so if I pull that 4 out of the square root of 4 is 2, and it's on the bottom, so I multiply by 1/2. And now inside my integral, I'm just left with cosine theta on top, and then in my square root I've pulled out the 4, so I've got 1 minus sine squared theta d theta. Now, remember, 1 minus sine squared theta is cosine squared theta. So if I multiply 2/3 by 1/2, that's just 1/3. And now in my integral, I've still got cosine theta on top. In the bottom, I've got square root of cosine squared theta d theta. So now I've got cosine and square root of cosine squared, which is of course just cosine, so these will cancel, and that's just 1. So now my integral, I've just got 1/3 times the integral of d theta, and that's easy to integrate, so I integrate that, I get 1/3 theta plus a constant. And now I substitute back in for my theta. I've got 1/3, and theta was equal to inverse sine of 3/2 x and plus my constant. So that is my final answer.